All right, let's talk about one of humanity's biggest challenges, getting fresh, clean drinking water from the one place that seems to have an endless supply, the ocean. But it turns out there's a massive, stubborn problem that gets in the way. So let's dive right in.
Just think about that for a second. The sheer scale of it is kind of mind-bending, right? You've got this vast, salty expanse, and we need to get trillions upon trillions of gallons of pure, drinkable water out of it. How on earth do we even start? Well, it turns out that one of our best methods really just boils down to a super simple idea: a filter. Okay, a really, really fine filter. But just like the one in your coffee maker, it has a major weakness. It gets clogged. And when that filter is supposed to be providing fresh water for millions of people, a clog is a huge, huge deal. So before we can get to the brilliant solution that we're going to look at today, we first have to really understand the problem. Think of it as a global scale plumbing issue. Okay, so at the heart of all of this is a technology called seawater reverse osmosis. You'll hear it called SWRO. This is the workhorse. It's one of the most important tools we have to fight water scarcity all around the world. This is incredibly important stuff. So how does it work? Well, imagine using a really powerful pump to blast seawater against a special filter, a membrane with holes so tiny that only the water molecules can get through. All the bigger stuff, like salt and minerals, gets left behind. Pretty simple in concept, right? And super effective. But here's our clog. All those minerals that get left behind, things like calcium, they don't just wash away. They start to build up, like a crust, right on the surface of that filter. This is called scaling. And honestly, it's the exact same thing as that chalky lime scale that builds up in your kettle or coffee machine at home, just on a massive industrial scale. Now, for years, the industry has had a way to deal with this scaling. But as you're about to see, the so-called fix actually created a whole new set of problems. The solution was to just add chemicals to the water. These things are called anti-scalants, and they're pretty clever. They're designed to get in there and stop those mineral crystals from ever forming in the first place, either by basically grabbing onto them or by messing up their shape so they can't stick to the filter. But here's the catch, and it is a big one. As the researchers behind this study point out, using these chemicals is expensive. And then you have the problem of what to do with all this chemical-filled water. It's a serious economic and environmental headache. And believe it or not, it gets worse. Turns out, some of these chemicals are like a delicious feast for bacteria. So by trying to solve the scaling problem, you can actually cause a whole new problem, a slimy layer of bacteria growing all over your filter. It's called biofouling, and it means you've basically just treated one type of clog for another. So yeah, the chemical fix is not great. It's expensive, it's bad for the environment, and it causes its own clogs. And this is where our story takes a really cool turn, with a solution that's just beautifully simple. What if, instead of adding more complicated stuff to the water, we could fix this with, well, with air? Specifically, with incredibly tiny bubbles of air mixed into the seawater before it even hits the filter. It almost sounds too good to be true, doesn't it? Now, we're not talking about your average bubbles here. These are micro-nano bubbles, or MNBs, and they have some really unique superpowers. First, they're unbelievably small. But here's the key. They have a strong negative electrical charge. And why does that matter? Well, the mineral bits that cause the clog, like calcium, they're positively charged, so opposites repel. The negative bubbles literally push the positive minerals away from the filter surface. It's like having a tiny, invisible force field protecting the whole thing. Okay, so we've got our two contenders. In one corner, the old way, chemicals. In the other corner, the new challenger, tiny bubbles. The researchers set up a head-to-head competition to see which one could actually keep the filters cleaner and working better. So just on paper, the matchup looks pretty one-sided, you know? You've got chemicals versus a chemical-free approach, environmental burden versus environmentally friendly, risk of slime versus no risk of slime. But the real question is, does it actually work better? Let's check out the results. Okay, this graph right here tells such a clear story. It tracks the filter's performance over 4 days. See how the lines drop? That's the filter getting clogged and the water flow decreasing. Now, look at that line at the very top, the one with the triangles. That's the filter using the micro-nano bubbles. It stays way higher and way more stable than all the others. It's just clearly working better.
And if that graph wasn't enough, just look at these images from an electron microscope. On the left, that's the filter with no treatment. It is completely covered in this thick, crusty mineral scale. It's awful. Now look at the right, that's the filter after 4 days with just the tiny bubbles. It is remarkably clean. I mean, the difference is just night and day. Let's just put this in simple numbers. After 4 days, the untreated filter was barely working, down to 56% of its power. The best chemical antiscalant did okay, keeping it at 68%. But the filter protected by the tiny bubbles, it was still running strong 86%. That is a massive, massive improvement. So this isn't just some small lab victory. This could be a real game changer for how we get fresh water. Let's talk about the big picture and why this really matters. First things first, the most important question, did it still actually filter the salt? And the answer is a huge yes. Even with the bubbles, the system's ability to remove salt stayed above 99%. So you get all these amazing anti-clogging benefits without losing any of the water quality. It's a total win-win. So the real takeaway here is pretty clear. By swapping out chemicals for simple air bubbles, we could make desalination cheaper, way more energy efficient, and so much better for our oceans. This is a huge step toward a truly sustainable way to make fresh water. And it just leaves you with this incredible thought, right? Here we have this super complex industrial scale problem, and the best solution turned out to be inspired by something as simple as a bubble. It really makes you wonder, what other massive problems out there are just waiting for an equally elegant and surprisingly simple solution?